Okay, finally, I'm going to show you an example of a proof. So these proofs are going to start coming up more and more as we begin to learn new theorems. Right now, because we're just in the beginning, I'm going to do this for you so that you can kind of look and see how this is all working. So what I know from this picture is that line P and line R are parallel to each other. I want to prove that line L and line M are parallel to each other. Clearly, I've taken from a picture of an already solved proof, so those arrows are already on L and M, but we're going to work through and prove that they're parallel. So what I care about are P and R and the two transversals that cut through them. So I'm going to go ahead and do two separate circles. So there's transversal L and here's transversal M. So it's really easy for us to want to jump ahead and look at a relationship between 1 and 3. It already gives that to us, but I am just looking at the transversals that I know are there. So looking at my two transversal groups, in my yellow groups, there's only angle 1. That's the only one I know. So I'm not going to do anything with that. But when I look at my green, I see that I have angle 3 and angle 2, and they're alternate exterior angles. And because I already know that P and R are parallel to each other, then I know that angle 3 is congruent to angle 2. And that's everything I know for my first given. So now looking at my second given, so this was my first one. Looking at my second, I know that angle 1 is congruent to angle 3. So now kind of weeding through the information that I have, if I know that angle 3 is congruent to angle 2, and I know that angle 1 is congruent to angle 3, then I can go ahead and say that angle 1 is congruent to angle 2 because of the transitive property. Finally, for 3, so finally, I want to prove that those two lines are parallel. Now I'm going to look at my relationships in the opposite way. So looking at instead of vertical to horizontal, now I have two other groups. With these opposite groups, I can see that angle 1 and angle 2 are corresponding. Since those two angles are congruent and they're corresponding, then we can say that L is parallel to M because of the converse of the corresponding angle postulate. So this is a lot of crazy brain dump things. So I'm going to take the information that we just found out. I'm going to clear it because I'm out of space. And I'm going to write all of this in a neat and clean 2-column proof. So I have my statements and my reasons. First, I'm going to list our givens. So we know that P is parallel to R, and that angle 1 is congruent to angle 3. We then said that angle 2 is congruent to angle 3, because of the alternate exterior postulate. Then we said that angle 1 was congruent to angle 2 because of the transitive property, which says that if two things are congruent to the same thing, then they're congruent to each other. Finally, once we knew 1 was congruent to 2, then we can go ahead and say that L is parallel to M because of the converse of the corresponding angle postulate. Okay, so again, I modeled a proof for you. This could be very, very overwhelming to you, and you might still be in a place where you don't get it at all. Don't worry. If you're still in that place, that's very, very normal. We've only been doing these for less than a week. Like should not necessarily click yet. If it does, that's awesome. Your brain works in a very logical way naturally. But again, we're going to keep doing these baby step holding hands until you really are solid on how exactly these are supposed to go.